Okay, let's look at using derivatives to find some aspects of physics, kinematics. So remember that the first derivative is always velocity, and then the second derivative is acceleration. So with that in mind, we're going to use those properties to solve some of these problems. Okay, so the first problem, it says a baseball is thrown up in the air from the upper deck of a baseball stadium with an initial upward velocity of 60 meters per second at an initial height of 10 meters. Its height in meters after t seconds is modeled by the following function. Okay, so this is the position or distance, but in this case, since we're throwing something up and down, it's going to be the height. And so write a function for the velocity. Well, that's just the first derivative. Now, we can do that super easy here, right? We can just say, well, 60t becomes 60 minus 10t, and now I have that, right? Next, we'll find find the time when the velocity of the baseball is 0. Well, we just need to set our derivative equal to 0, or our velocity function. 60 minus 10t, well, that's pretty easy to do, right? We can see that if we divide both sides by negative 10, that t equals 6, and we're talking seconds. So that would be a long time, but that would say that it took 6 seconds for the ball to reach a high point, right? So if that happens, right, it says, what is the height of the baseball when the velocity is 0? Well, when the velocity is 0, it's at 6 seconds, right? And so we would go and put this back into our initial function, right? And would say, what's h of 6? So this will require a little bit of calculation, but it's not that bad. So we're going to have 6 squared plus 10 here at the end. So 60 times 6, that's going to give us 360. And then we have 36 times 5 is going to be, that's going to give us, well, I always think of this as like 30 times 5 would be negative 150. And then 6 times 5 is just 30, so that's going to be negative 180 plus 10 here. So I'm going to have 370 minus 180 is going to leave me with 190. All right, so the height of the ball, that would be pretty high up, right? But maybe it would have to be launched out of something, but that would be 190 meters. Okay, let's do the next problem, and we're going to go ahead and look at a kind of a different problem, but very similar process. A particle is moving along a straight line. Its function of distance with respect to time is given by s of t equals 2t cubed minus 24t squared plus 90t. Okay, now you can do these derivatives by hand, but for this one I'm going to use the calculator just because it will speed up the process. And so what I want to do here is, well, first I got to make sure I can record my initial function. So we have 2t cubed, and I'm going to go ahead and use t since that's a variable that's given. And then that's 2t cubed minus 24t squared plus 90t. Okay, so I'm going to go ahead and store that because I want to store that as, we'll do it exactly as it's given here, s of t. Make sure you always use, if you start with t as your variable, you got to continue to use that. Okay, so let's say write a function for the velocity. Well, that's pretty easy now. We can just go to calculus, derivative, and we're going to say d of dt, and oops, that's what I'm trying to find is v of t. So, but I already have s of t, so I take the derivative of that, and now I have v of t. So I'm going to go ahead and store that. And remember, I'm using Control VAR to store. And now I got this. So let's record that as our answer. So we got 6t squared minus 48t. So our velocity is 6t squared minus 48t plus 90. And now I'm going to use that. It says find the times when the particle is at rest. Well, I could set this equal to 0 and solve it by hand, but I could also just do that in the calculator. And so I'm going to go to Menu, Algebra, solve. And now since I have this stored as v of t, I can say v of t equals 0, comma, and then make sure you use the same variable. Don't want to use x because you're working in the variable of t. It has our time is forms the, or sorry, it takes the place of x. And so we got two solutions. We got equals 3 seconds and 5 seconds. Okay, so we're going to record those answers. So that's time equals 3 seconds and also time equals 5 seconds. So now it says, what is the position of the particle at the times when it is at rest? Well, in order to do that, we're just going to input 3 and 5, our two answers, into our original function. So notice that is also really easy to do with the calculator because you can just go, well, I already have this stored as s of t, so we're going to do 3, and then we'll do 5. So we have the position here is going to be 108, and then the other one's going to be 100, okay? So moving along here, write a function for the acceleration of the object. Well, that's just going to be the second derivative. Now, you can do this by hand, but we're going to do it with the calculator as well. But if you do it by hand, you can see from above here, this becomes 12t minus 48. And so I'll go ahead and store this in the calculator, but we go menu, calculus, derivative, and we're going to keep using t, and I take the derivative of velocity, and there you can clearly see that you get the a of t here. So we're going to save that as our acceleration function. And the final part, it says, what is the velocity of the particle when the acceleration is 0? Well, I'm going to go ahead and do this by hand, but then I'll show you at the end how you can do that with the calculator as well. So I have a of t. I need to find out when the acceleration is 0. What's the time when the acceleration is 0? Well, I have 12t equals 48, so t equals 4 seconds, right? So then I got to go back to my velocity function, and I got to input 4 for t, right? So in order to do that, I'll do that with the calculator since it's going to be pretty easy. So I already have my acceleration. If you were to, just try to find that t equals 4 with the calculator, you would just go, we would go algebra, solve, and we would say, well, when is a of t equal to 0? And then remember, comma t, and you get t equals 4. But now I want to figure out what is the velocity at time equals 4 seconds. So I get -6, right? And when I get the -6, we don't really have negative velocity, but it just has to do with direction, because you have to keep in mind what you have is a particle moving back and forth, and you're having a negative velocity there because it's moving to the left. It's moving backwards.